pumping.
What if I told you there's another way? All I'm offering is the truth, nothing more. Can targeted memory reactivation, TMR, help you learn in your sleep? Studies show that TMR can enhance the consolidation of declarative, procedural, and emotional memories. This would suggest that TMR is a scientific way to boost learning during sleep. Memory consolidation occurs during slow-wave sleep. As seen in this figure from Nature Neuroscience, new memories are initially bound by the hippocampus for temporary storage, and during subsequent sleep, memory traces are reactivated and redistributed for more permanent storage in the neocortex. Now, normally reactivation happens spontaneously during sleep, but TMR provides a way to selectively control which memories are replayed. By introducing sensory cues, tones, odors, vibrations linked with learning, TMR can bias the brain to strengthen specific memory traces. For example, take this fragrance. If I smell this delicious fragrance while studying, and then it is exposed to me on cue during slow-wave sleep, this would be an example of the TMR protocol. Now I'm sure you want some experimental evidence of TMR actually working. Here you are. In their 2012 study, Antony and their team show that auditory cueing enhances skill learning. Participants learned motor sequences paired with musical tones. When those tones were replayed during sleep, participants showed significantly better spatial and motor performance the next day. This demonstrates that reactivation during sleep strengthens specific skill memories without conscious effort. Additionally, in their 2025 study, Cho and their team showed that reactivation frequency matters. They compared single and multiple cue presentations during naps. They found that moderate cue repetition strengthened memory, but too many cues led to interference or diminished returns. This would suggest that an optimal dose of reactivation exists and would indicate that effective TMR depends on precise timing and frequency. A 2020 study by Hu and their team analyzed the results of over 2,000 participants across multiple TMR experiments. They found a positive effect of cueing during slow-wave sleep on declarative and procedural memories. The effect of cueing was strongest when the cues are unobtrusive and matched tightly to prior learning. Now, it's important to discuss the limitations of something even as great as TMR. A first would be that TMR is not a shortcut for learning new material. It enhances retention, not acquisition. Another would be that its effectiveness depends on not only the accuracy of the cue timing, but also of the sleep stage detection, as overcueing or mistimed stimuli can disrupt sleep architecture or have no effect. Another consideration is that TMR effect sizes vary considerably, with some studies showing no benefit or even impaired memory when the cueing causes interference. To conclude, my friend, TMR capitalizes on the brain's natural consolidation processes to selectively strengthen learned information during sleep. Yes, when cues are properly timed during slow wave sleep, TMR can meaningfully enhance learning outcomes. Far from being wasted time, sleep would be an active phase of learning, turning your dream of studying in your sleep into reality. Because dreams really can make you smarter.